Thanks for the organizers and all of you who reviewed the papers. Give us the opportunity to present this work. I'm Nikhil. This paper is led by Isamar. She has done a lot of the hard work. So I wish she could present, but I'm just standing in her place to talk about this work. This is in the context of Zillow, algorithmic failures, consumer response. I'm going to spend a fair bit of time in the first 10, 12 minutes going over the research context, because Zillow and business model might not be something that all of us might be very familiar with. So I'm going to start there, research context and research questions. And thanks in advance to Puneet for the discussion later on. I looked at the slides, they are awesome. So I'm going to try to give him more than 15 minutes to talk about it.
You're just setting me up for failure.
Okay, so I broadly think of this as some research, the overlap of two streams. So one is AI pricing algorithms. AI is influential, fewer errors, scales easily. So there are also researchers talking about challenges in adoption and trust on AI and algorithmic aversion. So in spite of both the pros and the cons, so it does determine what we watch, what we invest in. Most importantly for this talk, how we price. And when you think of AI algorithmic pricing, you think of Uber sets prices, Airbnb. You can also think of Kelly Blue Book in this context, which prices used cars. What we're going to talk about is algorithmic pricing in context of home sales, which is just one stream of AI algorithmic prices. The other stream that this overlaps with is the housing market and various platforms that have come on the scene in the last few years. Zillow, Redfin, Opendoor are fairly prominent examples. And the reason these platforms have come on the scene is search and pricing tends to be quite inefficient in the housing market. This is just public service announcement. This has nothing to do with the paper, but this just happened a month back. I'm sure a lot of you were super happy for many years, the 6% commission that agents make of all home sales. That might be going away. Hopefully that goes away. In the short term, for all of these platforms, it's going to be an issue because they're all kind of making revenue off the 6% that they charge. But in the long run, I feel that these big tech platforms in the housing market might have a lot more to do when this commission goes away. So I feel like in general, housing market platforms are going to become a bigger thing in the future. So in this context, AI pricing algorithms and these platforms, we are going to focus on one of the platforms, that's Zillow, as an example of what these platforms are doing to make, what kind of business models are they following. So Zillow has sort of two primary business models, had at least two primary business models. First, on the left-hand side, they have an ad-based business model. The idea is they have informative content on every home. That leads to consumers paying attention to that content, visiting the web page frequently. If you're a homeowner, you visit the web page to look at the estimate for your home, other information about your home on the web page. If you're a buyer, you visit Zillow to search, browse through many homes and their details and information. So informative content that leads to consumer attention so they can sell ads to real estate agents and services. That's their first and the primary business model. One important element of this business model is Zillow's Zestimate. And Zestimate is an AI-based estimate of the current value of it. So what would this home sell for right now, based on what similar homes are selling for right now? It's not future prediction, but estimation of what the current market value of this. This estimate is externally visible for every home that you visit. So if you can see this snapshot, you can see the estimate for a home is about $1.491 million. And Zillow often publishes publicly about its algorithm, updates to the algorithm, and how it's been improving over time in the last few years. Zillow does point out a very small error in its estimate. So I think this was published last year, where they said that the median error of their estimate from the eventual sale price is just 2.4%. Seems pretty impressive at the face. There are also a few papers out there that talk about the impact of Zillow's estimate on the eventual sale price. These papers say an impact of 5 to 15%. Seems it's not too large, but also it's not zero. There is some economic impact. I should point out that the authors for these papers, one of these are my paper. Manchanda, who is also a co-author on the paper that I'm presenting. None of these papers are published yet. All of these are work in progress. This is a field that's kind of burgeoning, and there's some initial evidence that Zillow's estimate might have some effect on the sale price.
Sorry, is this impact positive or negative?
So it's on both sides. So think of it as if you were to add an error of $1,000 on Zillow's estimate, this would say that the sale price would go up by $500 or $50, 5%. So it's gonna, if you shock the estimate downwards, it's gonna shock the sale price down. Zillow had a second business model. This was a home flipping business model. The idea was simple. They would buy a home, they would upgrade the home, and they will sell the house within 3, 6, 8 months time period. This Zillow offers business relied, at least we believe that it relied on their AI-based estimate of future value. So it's a little bit different from Zestimate. Zestimate is current value. If you are in a home flipping business, you want to estimate what the value of home would be a few months later. So we believe that this relied at least somewhat on an AI-based estimate of the future value. This estimate was proprietary. This estimate was not publicly visible. And Zillow does not publish any details about what algorithm it's using, how accurate it is, or any of those information. So this is just people's belief that internally they have data science AI teams that built a model to predict future value, and they were using that to figure out what homes to buy, upgrade, and sell as part of this business. At its peak, in Q2 2021, Zillow offer business was responsible for 1% of all home sales in the US. It's quite sizable if you think of how capital intensive this business is. In some cities like Phoenix, this accounted for about 5.9% of all home sales were to Zillow's iBuyer. What is interesting to us is this Zillow's iBuyer business called Zillow Offers publicly was shut down. It failed in November 2020. And this is a news report that came out in November 2021, where the CEO says Zillow had failed to predict the pace of home price appreciation accurately. So they're kind of placing the blame on the algorithm or AI. Now, once this news comes out, the CEO, Zillow CEO is kind of putting the blame on the AI. We see other news articles. This one is on Wired, which is saying why Zillow couldn't make algorithmic housing prices work. And then from that, people are raising questions about the estimators. So even though those two business models were potentially using two different AI algorithms, people are making a connection. If you failed on that, algorithms that you're using are questionable. So what about the estimate that you're using on this other? There are out there other theories of why Zillow offers failed. While some theories and the CEO directly is blaming AI and algorithms, there are others who say that the Zillow offers business failed not because of AI, but because of unexpectedly high labor cost to make the home operate. It's not decisively, you can't tell which of these were the root cause. But that doesn't really matter to us. At least the perception in the market was that the AI and the algorithm had something to do with the failure. And as soon as you have that perception, you have some questions about Zillow's estimate. So this is the main research question that I'm going to talk about two research questions. This is the first research question that we're going to try to answer, which is, did the failure of Zillow's iBuyer business lead to loss of trust in its estimate? And how much trust is lost? And this relates to literature recently that's talking about trust in algorithms. And a lot of it looks at simulated environments in the lab, where in these examples, students or hospital operations or call center forecasting, you have subjects who are shown an algorithm, and then algorithms errors are revealed to them. And then you see how the subject's usage of the algorithm changes after they know about them. These are lab simulated studies. We also have some studies that talk about algorithmic transference. The idea that there are subjects who interact with one algorithm, they're informed about failure of a related algorithm. And these studies check how does their usage of this primary algorithm changes after they know that a related algorithm has failed. And the idea of algorithmic transference is if one algorithm fails, I might also stop trusting the first algorithm. So we're related to these 2 points. More broadly, I think traditionally you can also think of this as one product of a company failed and you might lose trust in either product or the same. This is particularly important because there are a lot of companies out there that are now publishing multiple AI algorithms. I think the most prominent example that comes to my mind most recently is probably the failure of Google's Bard AI, Gemini AI. I would be curious to know what happened to Google Cloud AI revenue just before and after that Google Bard AI failure. So in that context, we feel like we are providing field evidence from one of the most prominent public AI failures that has happened in the recent time. The second question that we're trying to answer is, okay, once we establish that there is a loss of trust on the AI, what is the impact on the consumer's pricing decision? So if I'm a homeowner and I was using Zillow's estimate as one of the important signals of price or demand in the market, set my listing price for my home, how will my listing price decision change once I have lost this important informative signal of price? And this relates to literature on pricing under demand uncertainty for one-of-a-kind product. If you think of homes, each home is unique. Similarly, used cars, art, peer-to-peer loans, they're all examples where each product is unique and there's no manufacturer that's setting the price. Airbnbs are another example. So in these markets, algorithms are particularly useful because they can inform the seller on how to set prices. As a seller, if you set the prices too high, you might not be able to sell. If you set the prices too low, you're obviously sacrificing what revenue you could have earned. So in these markets, it's particularly interesting to see what happens if there's such an AI failure and you have one less informative signal of pricing, what would happen to the prices over? So we believe that this, while we are doing this in context of housing market estimate, this should have some implication for algorithmic prices beyond the housing market. One example, I think, is Airbnb. What if tomorrow people lose trust in Airbnb's smart pricing? What would happen to the pricing of short-term rentals? And just as a teaser and a spoiler, what we're going to claim at the end is after the loss of trust, the prices are going to go up. It's not be a huge effect. It's going to be a small economic effect, but overall, the prices are going to go up from the loss of trust. So we're going to focus on listed home, but the same effect will happen for the sale prices. So both the listing price and the sale price.
The share of sold houses change.
Let me see if I'm able to answer that question. So we look at time on market, we look at list price, time on market, and sale price. Time on market might indirectly answer that question.
So you said that Zillow's home buying mistake was they overestimated the value of prices. Right. So is that correct?
I'm not making any claim for whether they overestimated, underestimated.
But they didn't get.
We know that they're possibly using some AI, and we know that they failed. So it is a reasonable hypothesis from that they were broadly overestimated.
So the true prices were actually lower. And then if the true prices were actually lower, then why would prices go up if they fail? If I'm a Bayesian updater and I get a signal that Zillow's prices were optimistic, will I revise this down?
Yeah, so I think that's going to be. I'm going to talk a little bit about the theoretical hypothesis of why we believe the prices are going to go up. I'm going to come back to say that the prices are not, so there is a valid mechanism that after the failure, I believe that Zillow prices were more than they should have been or less than they should have been. But also make an argument they were less than they should have been because by keeping the estimates low, they could have helped their own iBuyer buy at a lower price. There are mechanisms that go both sides, but I'm going to say that the mechanism that we focus on is on pricing uncertainty of the seller and the buyer without any claim on whether the price were biased upward or downward in one direction. The price uncertainty is increasing on both sides.
Could it be that they were failing to predict the future, right? Future price. So probably they were overestimating the future or underestimating the present, right?
Yeah.
So maybe once we are looking at the estimate for the current price, actually it was an underestimate, right?
Yeah. Yeah.
So that's why it could be another explanation why prices will go up, right?
Yeah. That explanation would be supporting this, but I would actually discard both of them. I feel like rationally, I don't, and maybe I'm biased. I feel like I like estimate and Zillow. But I'll try to capture all of those when I come to it. Okay. So even before we go to the data and the empirics and all of that, just a sense check. We researchers like the idea of AI fails and the AI, what happens to that? But come on, like people really thinking about that? Do they think of one failure and think the other AI is wrong? We did a brief survey on this, and I'm going to show one example of what we did. So we had people look at publicly available information on Zillow and Zestimate. What is Zestimate all about? All the AI details of it, whatever they can understand. And we asked them to say, on a scale of 1 to 7, do you trust Zestimate if you're a homeowner? We get some number, 4.688 on a scale of 1 to 7. That's how much people trust Zillow's estimate. We then also give them publicly available news articles on the failure of Zillow's iBuyer. That may or may not be making any claims about Zestimate, but they're just saying that Zillow's iBuyer business has failed. And then we ask people the same question about the trust on Zestimate on a scale of 1 to 7. And we do see that the trust for people on Zillow's Zestimate drops after learning about the iBuyer failure. So at least there's some sanity check that people are doing some transference in their mind. If one fails, I have doubts about the other area. So that sort of gives us some foundation that we can sort of look at this empirically. So let me next go into the data and the model-free evidence, and then I will eventually go to the theoretical hypothesis.
Do you think this transfer is just only within the brand, or now I don't trust Redfin estimate as well?
I hope that we will be able to look at that. So
These are from public records, right? So the sales are from public records.
yeah.
So you have the listing across both platforms.
Yeah, I would need to know the Redfin estimate of that home just before it was listed at the time. That's the tricky thing to find out. All right, so we are looking at about 28,000 properties that are listed for sale in Boston and Pittsburgh in June 2019 to May 2022. The most interesting important point to remember is Zillow's iBuyer business was not active in Pittsburgh and Boston. So there's no direct effect of the iBuyer shutdown in these markets. The only effect in these markets is through people's loss of trust on Zillow's estimate. So this is what Zillow's webpage looks like. As an example, this home has a sale price of 1.4 million and its estimate of 1.49 million. We collect that and a bunch of other details on this webpage. So in a simple example, the data that we're going to look at. So if you think of one home over time, a home is receiving a different estimate almost every day, every week. And so we collect those snapshots. Let's say this home is eventually listed at $1.5 million. Then it spends some time on the market and finally it's sold, let's say at $1.41 million. So we are going to focus, the first statistic that we're going to focus on is the deviation of list price from the estimate. So list price 1.5 million and its estimate just prior to listing. So in this example, that should be $0.06 million, or you could also say the listing was 4.1% above the estimate. So that's a statistic that we're going to look at. We'll also look at the time on market and the sale price. I feel like in these 40 minutes, like if I can convince you about the list price, I would go out of here satisfied. In sale price, time on market becomes a lot more convoluted and complex. So I wouldn't set the expectation of being able to convince you much about the time on market and sale price just yet. So we do in the paper study a downstream impact of sale price and time to sale, but less on that right now. this is what the descriptive statistics look like. If there's something you want to focus on to get a sense of this, sale price, the mean sale price is about $500,000. There was so about 28,000 homes in all were listed. 25,000 of those were sold at a mean price of $42,000. One big elephant in the room, it's something that I have to address before I proceed. A lot of the data collection happened during COVID-19. So COVID-19 was obviously a very unique event. It is a valid question if this itself caused the iBuyer failure. It's also valid if this also caused changes to consumers' decision. In general, we have a perception that during COVID, prices were crazy. How can you talk about listing prices, sale prices? COVID-19 was pretty crazy prices. So this is what the prices in aggregate looked like during COVID-19. So this, I think the gray bar is hardly visible, but somewhere here is the beginning of COVID-19. So before that, the prices do go up 22% every year, and they were going up much faster during COVID. So even though during COVID, I think the future always looked way more unpredictable. Going back, if you look at this, yes, prices were going up faster, but there is some method to the man. They were just going up faster at 4 or 5%. So it wasn't like they were just swinging back and forth all the time. So in aggregate, it looks like there is some reasonable trend to the prices in the COVID-19 period. So that November 2021 is the iBuyer failure event. That's going to be sort of our treatment. Our control will be same time the year before and 2 years before. So one of the control years is during pandemic, one of the control years is before pandemic. So we're going to have results that use both as controls. One is control, the other one is control, and the results are going to remain the same.
All right, do the prices in the cities that you are studying the same as this?
Broadly speaking, yes, that they were growing slowly and they were growing much faster. And we're also going to control for neighborhood level average prices at a week level when we do the econometric specification. Okay, so I'm going to come to the empirical strategy more formally later, but very quickly, the way we're going to identify this, and this trend is hypothetical, this is not a real trend. So we'll look at some outcome measure over time. November 2021 is the iBuyer shutdown. We're going to look at before and after. I'm going to compare that to control periods last year and the year as a DID specification. Okay. So aggregate trends look, they were growing faster, but they seem pretty consistent. But still, during COVID, the market was still unpredictable. Sure, going back, you feel like, okay, the trends were quite consistent, but during COVID, it was just an unpredictable time. You always felt like, okay, there might be a lockdown, there might be some other government policy, things just felt a lot more uncertain. So it's possible that during this period, estimate and list prices had no relationship at all. People just making decisions based on their fears or optimism or pessimism all over the place. So any effect that we are picking up could just be unreliable during all of this COVID-19. So let me show this model-free evidence. And this one, if you look at the time scale, I'm cutting this off and showing just before the iBuyer failure. So that's a little bit of a mystery. Next slide is going to reveal what happens after the iBuyer failure. And the y-axis is the list price deviation from the estimate. If you broadly look at the last few years, and generally speaking, even beyond this, the deviation of the list price from the estimate is usually going down. In particular, there are a couple of times it's going down a little bit faster than the other times. So in particular, if you see before COVID and after COVID, the deviation of list price from the estimate reduced. My likely explanation for that would be that it's harder to tour home, it's easier to search online, so you can probably rely on something like Zestimate a lot more to do your search and browsing. The same thing also happens in 2021. The yellow bar reflects one instance where Zillow publicly upgraded its algorithm to use neural net. Whenever Zillow upgrades its algorithm, again, it's likely that the deviation of this price from the estimate is going to come down. Generally speaking, over the last few years, this deviation has been going down because Zillow improves its algorithm. People use this algorithm more, so the deviation between consumers' action and this estimate has been reduced. There's also a possible hypothesis that while the deviation is going down, maybe it's entirely explained by Zestimate getting better. Like it's possible that as a consumer, I am not using Zestimate any more than before, but just because Zestimate is getting better, it's predicting my behavior a lot better. To rule this out, we do have information on when exactly does Zillow make algorithm updates. And we can also rule out that as an explanation for changes in this price deviation from Zestimate.
So the Z estimate itself is based on all these things. And we're comparing that to the homes that sold, which are just the sold listings.
Yeah.
So wouldn't it be possible that the Z estimate is actually accurate in the sense that there's some selection that sells? See what I'm saying?
So one, with the timeline, the Z estimate that I'm looking at, that one is going to happen well before the sale happens. So I'm going to compare that Z estimate with the sale that happens. So this hasn't become part of the sample yet.
Yeah, I get that, but the Z estimate itself is based not just on that home, but it's an algorithm that includes homes that don't sell.
Yeah.
But the sold price is only conditional on sell.
So you're saying that's the reason why Z estimate will be biased?
Potential, I don't know, potential.
Yeah, I think that's valid. So we, in the long run, we look at
You're splitting everything, I'm sorry.
Thank you, God, thank you. We can go.
if you take sale price deviation and that's 0.001. So yeah, I think that much they've figured out. The AI team has estimate figured out how to not pick bias. Is there a faster way to go back? How much time do I have? You have.
15, a little bit more than 15.
Okay, so my mystery is also gone. So this is what happens right after the iBuyer failure. The deviation is generally trending downward, reverses, and it goes up. I do feel like this model-free evidence helps us out a little bit too much. I think when we're going to place the controls and the control year and all of that, the effect size is not going to be a crazy large effect size, but about 24% increase in the list price deviation before and after. Okay, so by looking at this, we have like some hypothesis that it looks like it's possible that the sellers are reducing weightage they place on the estimate because of this AI failure, because of loss. So with that, let me build a little bit of theoretical intuition on what should happen to the prices if I lose trust on this estimate. So if you think of sellers as constructing a posterior estimate using their prior and estimate, and then they use that posterior estimate to decide the list prices. If my weight on the estimate increases, the deviation between my posterior or my actual list price and this estimate should reduce. But if there's iBuyer failure, there's reduced trust in the estimate. So when constructing a posterior, I'm placing less weightage on the estimate, the deviation should increase, which is consistent with the model-free evidence. So this bit is still relatively straightforward, but what's harder to think about is what would happen to list prices overall. So yes, they deviate more from the estimate, but should they deviate more upward or downward? There are two ways to think about this. So if you think about just on the seller side, if I'm setting the list price and my uncertainty has gone up about what kind of offers I'm going to get. And let's say the buyer side hasn't changed at all. Let's hold the buyer side fixed for a moment. So if there's increased uncertainty about demand for the seller, there's a model for pricing and a demand uncertainty for one-of-a-kind product, which would say that as a seller, I would increase the initial list price. And as I learn about the demand over time, I'll cut prices and just take longer to sell. So that would say why increased uncertainty would lead the seller to increase list price. You can also think of this side of in terms of the buyer uncertainty. If I'm a seller and my uncertainty hasn't changed, But I know that the buyer's uncertainty has increased because of loss of trust, a lack of informative signal. I'm expecting offers that have higher variance. If I'm expecting offers that have higher variance, I'm going to increase my list price to take the best advantage of these high variance offers. So both of these theories would say that the list prices should go up. This is all based on uncertainty of the seller and the buyer. There are also theories, I'm saying Reddit, but I know that some of you felt these are possible theories as well. So the idea that Zillow was keeping its estimate low to help its Zillow offer business, the current estimate low. So that would suggest that Zillow's estimates were too low and sellers should increase list prices. There's also this theory that Zillow offer failed because Zillow bought properties were too high. So the estimates were too high, sellers should will lower list prices.
These papers are cited, do they assume buyers are risk averse or just?
No, no risk aversion.
Also no competition,
Competition between buyers?
sellers and buyers, right? Others also.
I don't know why that would change these conclusions.
It's like,
Yeah, but it would change behavior, the details of it, but I don't know why that would change, the list prices wouldn't go up.
so risk aversion came from lower. And this was the uncertainty of what is it, but again, I haven't done the analysis. So
Yeah.
theoretically, I would say more risk averse, I don't know if I'm going to sell or not. Competition, if we have more uncertainty, just competition, I'm sure we're probably.
All right, let's think a little bit more about it. All right. Okay, let me speed up from there. So I'm going to skip the hypothesis on time on market and then move directly to the empirical strategy. So this is what the main specification looks like. So we have the main outcome variables, deviation of list price and estimate, absolute. We have treated, which is indicated whether the period is the treatment year or the year before, after, and this is the coefficient of interest, the after and treated, the coefficient of interest. We have controls for property characteristics, market conditions, listing agent size, as much as we could get from that Zillow webpage, essentially. Also fixed effect for weak fixed effect and zip code effects as well. This is what the event study looks like. It would be nice if it was clean and parallel, but generally the trend is going down before the treatment. And that does happen because there was a significant algorithm update about 5 months before the treatment. So generally we see people's reliance or the deviation to be going down even before this treatment happens. And it changes course and goes up after. So this is some descriptive statistics on the variables of interest. So the one that we're looking at is the list price deviation, which has a baseline level of 4.3% overall in the data. And the results, we find that this list price deviation increases by 24.51% after the iBuyer failure. To be able to interpret that, think of a home that has an estimate of $1 million. So before iBuyer failure, I would have expected the list price to deviate from this estimate by an average of $40,000. After iBuyer failure, I see the list price deviating from the estimate by $50,000. That's additional 24%. That's this result holds after accounting for a lot of other controls, changes in housing market conditions, which is captured through monthly city median sale prices, list prices, time on market, number of listings, also listing agent size. We also have robustness checks that look at whether the housing stock composition, sort of houses that are being sold have changed before and after the iBuyer shock. We also use 2 years as control. We also use just 1 year post-COVID as control, 1 year just pre-COVID as control. It all checks out. We also use just Pittsburgh and just Boston as our data. We get the same. So given our econometric study, there's still a valid concern if there were other unobservable events around 2021 that may have triggered the iBuyer closure. So it's possible there are other factors that are both causing the iBuyer closure. and causing seller decisions to change at the same time. So when you think a little bit more about the Zillow iBuyer shutdown, it wasn't a very sudden event. We do see that leading up to November 2021, Zillow was already reporting losses in its iBuyer business. So this was not something that was triggered at the moment because of an external event. Zillow's iBuyer was doing poorly for the 3-4 months preceding this shutdown. So the iBuyer closure was likely not a sudden decision triggered by an unobserved factor. It was something that was kind of building up to it. So we don't think it's likely that iBuyer closure happened because the government locked down a particular city or made it harder for them to do business. But it's still possible there are other unobserved factors in November 2021, coincidentally at the same time, that are causing those sellers to change their list pricing decisions. And to be able to control for that, something that we haven't done yet that we are trying to do is to find other control groups where iBuyer failure should have no or less impact on their pricing choice. So we have looked at we're trying to do a few of these. I think one interesting one is to be able to look at sellers who work with higher quality agents, because we believe that for those sellers, maybe they never relied on Zestimate at all to begin with. So their pricing decision shouldn't have changed before and after the iBuyer. So that hopefully adds another level of robustness to these results. So just to summarize in the last few minutes, so let me skip the table.
You have 5 minutes, until 15.
Okay, so in terms of the list prices, the absolute deviation increased by 24.5%. The non-absolute deviation increased by 1.4%. The first one is simply explained by the idea that if I don't rely on Zestimate, my deviation in the estimate is going to go up. The second one, the 1.4% increase, is explained by increase in buyer uncertainty and seller uncertainty, both of which will result in seller increasing their list prices. So that's 1.4%. On the sale prices, we find the results consistent with the list prices. We find that the absolute deviation of sale prices to Zestimate also goes up, as well as the non-absolute deviation of sale prices from the Zestimate also. So the sale price is also deviating from the estimate more on both sides, but on average they're deviating on the positive side. But the effect size is smaller than that of the list price. So if you look at that as that result, just in summary, without going through the mechanism or what happened with loss of trust, effectively what's happening is, even though an iBuyer is exiting the market, the prices are going up. That's a little bit counterintuitive, but hopefully the mechanism of loss of trust and uncertainty kind of explains why this would happen in the market. And this overall is consistent with this theory on pricing and demand uncertainty for one-of-a-kind product. Time on market is, so the result of time on market that we find is there is a shorter time on market after the iBuyer failure. And this one, we don't have a theoretical hypothesis on this upfront. What prior literature would say on this is, if the seller's uncertainty increases and the buyer is held constant, then I would expect the time on market to increase. Because as a seller, if I'm less informed about the demand, I'm going to put up an initial higher list price and spend time to learn about the demand in the market. And so I'll end up spending longer in the market. If seller's uncertainty is held constant and only the buyer's uncertainty is increasing, so as a seller, if I'm expecting offers that have a higher variance, then the time on market is going to reduce. Because I'm going to increase my list price, but not as much as, in proportion, it's not going to be as much as how much the uncertainty has increased. So it becomes an empirical question. Whether the buyer's uncertainty is dominating or seller uncertainty is dominating becomes an empirical question. That's something that we can't upfront, we don't have an upfront hypothesis on which one is going to happen. So in this market in November 2021, the loss of trust, our results suggest that the loss of a buyer's loss of trust on Zestimate is dominating this interaction. And that's why we are seeing a shorter time on market. Based on those results, we feel that there's some implications for this beyond the iBuyer failure. So this is, of course, one of the first field evidence of loss of trust via algorithmic transference, failure of one AI, transference to another AI. It hopefully quantifies risk for platforms that offer AI. A lot of platforms now offer multiple AI algorithms, and there's an inherent risk. If you fail on one, consumers are going to have perceptions and beliefs about other AI that you offer. So we do try to quantify that risk. There are other algorithmic prices that have significant market influence. So Airbnb is one example. Kelley Blue Book, I don't think it has significant influence just yet. But what's interesting with this is Kelley Blue Book has a very similar iBuyer instant cash offer business, where they use this algorithm to place offers on a car, buy it, and then resell it. The business is not big, but very similar to what happened in the home sale market. In terms of future research, I think it would be interesting to look at. We do have this result on a dominating the fact that the buyer's loss of trust dominates over the seller's loss of trust. But that would be something that would be very interesting to look at more closely. We have also not compared. So what we have looked at is how the seller or the consumer in general loses trust on AI because of the failure of AI. But we haven't compared this to how the seller would lose trust on a human agent if a human agent was to make a mistake. That would also be interesting to compare if their loss of trust on AI is larger or smaller than their loss of trust on a human agent. With that, let me stop and hand it over to Puneet for the discussion.
Well, he's clearly a man of his word. He gave me 3 extra minutes. So, well, thank you for giving me this chance to discuss this paper. I should say that I'm really happy to see the success of this conference, second iteration, and I hope it keeps growing. These small, high-quality conferences are really good for, I think, developing our own work and PhD students and so on. So, kudos to the organizers for doing that. I'm sorry, I'm going to destroy Dante's. I'm sure he had a authoritative matching paper of referees and authors being written already. I'm not from Italy, not from the same town, so I'm sorry your name broke down. I come from a country where the name starts with I, so that's good. So it's always fun to discuss a paper, especially people I know are super smart. On top of that, people that I like. So I know Isamar and I know Nikhil. I don't know Runchan very well, and those two I like. I didn't say anything, but clearly the audience is smart enough to figure it out. So I also try to follow Grand Puba's instructions as a discussant to focus a little more on the big picture and do less of nitpicking. I think that was kind of his intention to use that phrase. I do have some nitpicking, and I think the nitpicking is only I want to help the authors to get the paper published, but I'll spend a little more time on the bigger picture going forward. All right. So just the obligatory first couple of minutes saying what does the paper do. So as an editor, it's a little bit, it's kind of pattern recognition now. So it's the classic causal inference paper in marketing, the template. You find and leverage a plausibly exogenous shock, and the shock here is the withdrawal of Zillow's iBuyer program. You find the outcomes of interest. The outcomes of interest here are sale price related to the Z estimate, sale price related to the list price, and time on market, all very meaningful, relevant outcomes. You establish a control group, and here they use a control group, same time period in 2 previous years. Use a DID and show that the shock has an impact on the outcomes you care about. Right? And you propose a reasonable mechanism. So indeed, they show an impact, and they propose a mechanism. It seemed pretty reasonable, loss of trust, because a company did something bad or made some mistakes, and so people lose trust. So on the face of it, is quite reasonable. So that's kind of the kind of template they followed. Now, when I started reading the paper, a few things did stand out to me. So the first one is obviously real estate markets are big and important. Also, all of us are, very interested in real estate, and in general, people get excited about real estate. And now we have data. We went back 25, 30 years ago, there was data, but the data were relatively sparse. So it's an important market. It plays into sentiment, it plays into people's feelings and beliefs about economies and so on. So it's a pretty important market to look at, and now we have the ability to indeed actually look. The notion of algorithmic failure is also something that is in the news. It's very topical. I would say there's kind of hysteria around AI. People run OLS and call it AI. Most companies, that's basically what they're doing. And stuff they were doing yesterday, which was not AI, suddenly they're doing the same thing, but call it AI enabled. So basically somebody hit a key on a keyboard and therefore became AI enabled. But we want to be, as researchers, we want to be part of the conversation. We want to be part of what's going on around. So this is really nice. There's a nice theory that I think Chiara Longoni and the co-authors have published on algorithmic transference, which the authors also use, and it's kind of topical theory. And they've done most of their work, as far as I know, in the lab. So now we are trying to see this in the real setting, which is again a nice thing to see, nice contribution. The other kind of cool thing is that it's ex ante, as Nikhil pointed out. It's hard to figure out which way the effect should go. And those are the kinds of questions we love the most, right? Because we can always come up with story reports. And so it's kind of interesting to have that situation. And I think they make a very nice case that it's not obvious. And I'm actually not going to talk about the COVID part at all in the paper because I think they've done an amazing job. I'm pretty convinced that the COVID issue is not material for their findings. I think this was not there in the paper, but Nikhil gracefully shared the slides with me, and I read through the slides, and I think that's fine. So they've been pretty thoughtful about many things. Okay, so that's kind of where my general assessment on the paper was. So this algorithmic failure framing, that's what I first started thinking about, going back to the big picture question, right? So the first question I was thinking about was, is this truly an algorithmic failure? So here's something that I did, which again, I was sharing with Nikhil. I went, in many of these kind of exogenous shock in the market kind of papers, the data generating process, most of the time, the data generating process is what we think should happen in our head, right? And that's what we use to motivate the paper. In reality, that may or may not be true. So I went back and did a lot of archival research using Factiva, which is essentially a librarian's tool to look at all sorts of media information, mostly textual information. It struck me on the way to San Diego that I should just probably use ChatGPT, right? But I'm old. I don't think of ChatGPT as my default search engine. Plus, I don't trust ChatGPT. So at least here I have to manually check a lot of these things. So I did this. So I went back and looked at some of the questions here. And he put up the pictures noting that the CEO blamed it on the algorithm, which was basically threw his entire team under the bus. But if you go back and look at all the stuff that happened before, there were many other reasons why they withdrew the iBuyer program. The algorithmic part was a very small part of the story, right? In fact, they knew, even people within the company, they knew that they were buying homes which were accurately priced, but they were paying different prices for them because they were given a target of 4,000 homes purchased per quarter. So there's many reasons that it's hard for me to think of this as purely algorithmic failure. So that's the first thing. Again, I have a lot of this kind of text. I'm just going to put it up there. You can read it at any speed that you like. The second one is, what is the notion of failure? Right? So is this really a failure? And the interesting thing is that no algorithm is perfect. So if you think about any algorithm, it's a failure. Because unless it's perfect and predicts 100% accuracy in outer sample all the time, it's a failure. So where is the failure coming from? So in the paper, the failure is denoted from the fact that they withdrew the product, right? So is it a failure of the algorithm or not? So think of the kind of thought experiment. If Detroit started making cars using Japanese Kanban manufacturing techniques versus their own old school techniques, and they withdrew a car, will the failure be ascribed to the manufacturing technique, or will the failure be ascribed to many other business decisions or not? So to me, the definition of failure here, there is a failure, but is it an algorithmic failure? It's a little bit unclear to me going forward. Now, you could say, you know what? None of this matters. And I think Nikhil said this nicely, which is, if people believe this is indeed the case, then that's what you should be focused on, right? So I went back and started looking to see if was there any evidence that sellers, who are the primary agents in this particular market, believe this was due to algorithmic failure. And actually, I couldn't find it. In fact, what I found was a quote from the guy at Zillow group, saying that most people don't even know about the iBuyer. So if they don't even know about the iBuyer program, it's hard to make a case that this is an algorithmic failure. And that's something I want to think about, and I will spend a little more time on that. I'll come back to think maybe we should rethink or recast this framing a little more differently, because some of the data generating process doesn't seem to be consistent. Now, is it completely inconsistent? No, I can't make that claim either, but at least it is not particularly consistent. The second part was this theory, because this theory sounded very cool. I didn't know about it. I knew that Chiara was working on this kind of paper. I did actually read the papers. And here's the key in this theory. The algorithmic transference-based theory basically says you punish the algorithm much more relative to a person making the decision. So if the algorithm made a decision and it was bad, you punish the algorithm or related algorithm much more relative to a person making the decision. So that there is a control group here of person in this particular theory. And in fact, the paper does say this very transparently. What I put in italics is that the fact that there is no person here. So we don't really have a person to compare against. So is it fair to call this an algorithmic transference theory? Again, it's not clear in my mind that is indeed what is going on. A couple of other things about this theory. So for this theory to hold, the same person needs to know about both algorithms, which means that a seller here needs to know about the iBuyer algorithm, needs to know about Z-estimate algorithm, and then based on what happened, needs to punish the Z-estimate or lose trust in the Z-estimate. Again, given the fact that most sellers didn't even know about the iBuyer algorithm, it's not clear that this condition actually holds. And we'll talk about whether this becomes a big issue or not. And to some extent, it's not as big an issue as it sounds, but it's very hard to kind of fit it with the theory going forward. The two products are targeted very different kinds of sellers. So there's probably some issue about seller mixes going on. And I'll come back. That's less of an issue than I initially thought. I made a mistake in reading the paper, but it's less of an issue. But there is something going on. I think I would say the other implicit condition in algorithmic transference is that the two algorithms are indeed distinct from each other. Right? There's no point publishing this. There's no transference if the two algorithms are exactly the same. And again, when I went back and looked at some of the data in the Factiva part, the Factiva research, it showed that the Z-estimate was actually an input to the iBuyer pricing. So it's not as if that the two algorithms were very different. They were so close together. In fact, the Z-estimate was a very important input. What does transference mean in that sense? Right? Because they're both exactly the same. So that's another thing that I was struggling with as I read this. So then I sat back and said, okay, maybe there's another way to think about this problem. And so the way I think about this problem is that, a company screwed up with one product. They recalled the product for whatever reason, right? The CEO blames the IT team or the ML people. There could be some supply issues, salespeople issues, et cetera, but essentially they recall the product. If they recall a current product, it has an impact on their existing product line. So to me, that's relatively unambiguous. And I think that's where, to me, the story is much tighter. Right? The challenge here is, of course, to figure out what do we know about this. And there's actually a bunch of research in the econ literature. I think Friedman et al. Is an econ, automobile is marketing, where basically people have looked at when one product gets recalled, what is the punishment on the other products? And typically it's a negative outcome on the other products. They've not only looked at the impact on the rest of the product line, but also outside on competition as well. So there is a lot of interesting stuff here. So does that mean all is lost? No, because this setting is somewhat different. It's different because there are multiple parties here, right? So unlike there's a manufacturer and there's a consumer, but here we have a platform, we have a seller, and we have a buyer. And it's not exact. I was breaking my head thinking about exactly how this would play out for all three people. It's not clear to me, which means that these guys can shed a lot of light. The other thing is that these products are information products. In most of these cases, it's like it's a Lego toy or it's a car or something. It's a physical product. Here, it's actually an information product. I'm not exactly sure what to make of that, but I think there is something there. There's some difference that we can exploit and tell a story around that. By the way, the stuff in blue is my feeble suggestions that solving some of the problems that I've outlined. The stuff in red are, one of my students complained that I always like to criticize. So I said, okay, I'll put that in red, but I'm also a blue guy here. So very neat. Thank you. Okay. So that's kind of the big picture story. Now let me talk about, there's a bunch of identifying assumptions in the analysis, right? And they're basically here. The ones that I think that are important are basically here. So I'm going to go through them one by one to the extent that how much time I have, and basically point out perhaps some solutions going forward. So the first one, if you notice that illustrative chart for the BID that Nikhil put up, the identifying assumption was that is the iBuy withdrawal exogenous. And it turns out there was a lot of complaining and leading up to it saying that this product really sucks. So the market had a lot of time to think about the fact that this market, or the part of the market that's interested in this actually knew that this was probably going to come. And in fact, even like a month and a half, 2 months before, they actually stopped the iBuy program in certain markets, and that was widely covered in the press. So it's not truly an exogenous shock in the way that we think we would like as researchers like our shocks to be, right? But then Nikhil and I were talking at lunch, and I'm not exactly clear whether this really hurts the paper or not. I would kind of think through this more carefully, and we're going to talk about it. But it's not clear that it's a purely exogenous shock. So that's something to think about. So one thing you could do, which is very simple, is to just look at kind of the pool of suppliers, the types of houses on sale in the months leading up to the shock. If there was nothing that was changing there, then maybe you could argue that sellers have not really kind of internalized the fact that this program, this terrible program, it may go away. So perhaps there could be some empirical control, and maybe there's a bigger kind of picture story, which is what is the causal implication of that, which may make this less of an issue. So I didn't, Nikhil mentioned this, but the relationship, this assumes the relationship between Z estimate and list price. And as he said, the papers are by pretty much the same co-author team, they're all unpublished papers. So while that is not necessarily a problem, it would really help if they could find other people who have said the same thing, that just buttress and strengthen their own arguments. The choice of control group, I'm sure most of you have a feeling of unease when you think about previous year as a control group, because previous year and this year, by definition, they're different and you can't control for time fixed effects. But I'm not sure that this is a really big problem here. I mean, in general, there is some unease, but I couldn't really pinpoint my unease in a very specific way. So I'm willing to kind of live with it, right? I think it's okay. There's a couple of things that bothered me, which is if you look at this, as he pointed out, this is actually not a very good kind of lead up test. There's a lot, there are differences going on here, especially 2 out of the 5 months we do see the differences, the event study. And here we see something that for 3 months, nothing actually happens pretty much after the iBuy withdrawal program, which again, you can say real estate markets are slow and sticky, but it's still a bit surprising to me given all the press and the build up that this is going on. So these are some things to maybe think about and see if you can get some better empirics to control for them. I don't have a better solution for a better control. So, I mean, I think they've done a pretty good job with whatever the constraints are. The last thing in terms of the outcomes, the time on market can be affected by multiple things, right? There's 60, 70 days after you put the list price, you can change the prices, your buyers can lose trust and so on. It's very hard to kind of make a case that there is a causal effect of the iBuy program on time on market. So to the extent they can control any changes on the seller side, they change the price, they buy advertising, they list with a different realtor company, et cetera, it would help them. But I would place a little less credence on the causal impact on the time on market. It's a nice downstream effect to have, but it's kind of tricky to make a very strong causal impact. Okay. Seller mix. So I think, like I said, this may not be a very big deal, but the two prices appeal to 2 different kinds of sellers. Why is that? Well, iBuying is essentially for people who are willing to sell their house quickly on cash basis. And they have a different valuation of time, waiting time, et cetera. I made that mistake. Nikhil very sweetly pointed this out that, use of Boston, Pittsburgh elevates his concern, and I do agree about that because the product was not available there. But for two things are still important to think about. One is that for algorithmic transference, the seller must be aware of both algorithms. And if the product was not even available there, and you're using that as an argument to say the seller mix doesn't change, then algorithmic transference becomes a weaker story. And the seller pool could still change. We don't know. So what could be a good control? Well, just control for the supply side. Control for the supply sellers, look at what houses on sale. Again, we have some idea that in these markets, this did not change the seller mix directly, and that would help quite dramatically. The trust mechanism seems very plausible. I did find some press coverage that was consistent with this, but obviously it cannot be directly tested. It's a limitation of this kind of work. The other thought I had, and I'm not sure this is something they need to do, is there a difference between trust in platform versus trust in algorithm? And if so, can we separate those two out? Does Zillow have products that are not algorithmically based? And can you see the impact on those? That may help kind of zero in the contribution a little cleaner. There are a bunch of other plausible mechanisms, and some of them came out. Not all of them are consistent completely with the evidence, but some of them are. For example, my first reaction was, as Carl said, I'm a Bayesian updater. They suck at one product. So I just update rationally that their pricing strategies don't work very well. So I'm going to rely less on them. So is it lack of trust or is it Bayesian updating in a rational sense? So again, hard to test many of these, but it would be nice if we could test some of these and try and rule those out going forward. There was a question about competition as well. Open Door is, by the way, the big player in this iBuyer market. So they would have changed their strategy quite a bit as a result of this. Okay, so moving forward, I think I would say think through the framing a little more. If you want to stay with the algorithmic transparency framing, you have to make a stronger case. I think the product recall one is somewhat unambiguous and uncontroversial. The other thing also I was thinking about, this is where is the platform part of the paper? I don't really see much of the platform part of the paper except the discussion of buyer trust in kind of a derived or indirect way. So one way to think about that is think about the network effects. What does it happen to the seller and seller effects? What happens to seller and buyer effects? What happens to buyer and buyer effects? And maybe kind of tell more of a platform story as opposed to a product recall story if you want to stay with that. You buttress support for the identifying assumptions. I know I'm old, so I'm dating myself here, but this is a very famous song. I would sing it if I could sing, but I don't want to torture you. But there's something going on, and I don't know exactly what it is. So there's lots of things that don't worry me, but there are lots of small things that also worry me. So buttressing this would be very important. Try and rule out as many of the non-cluster mechanisms as possible. And then the last thing is going outside of Zillow. And this is put my editor hat on. We are all in this platforms conference because we all love this stuff. We get excited about this. But part of our job is to also excite people who don't work on platforms, right? And so I would encourage the authors to think a little more going out there and getting them to get excited about it. So one option, and I think Nikhil alluded to this at the end, you compare seller behavior in fixed price offers, like I think Carvana and these car companies also have started doing that, in iBuyer versus the marketplace. And that can transcend just the simple platform housing setting. So that'd be kind of cool if they could pull that off. So hopefully this was helpful. Thank you again, and best of luck with the paper.